So before lunch, we heard about digital engineering and digital standards. Another groundbreaking technology is also reshaping our economy, driving innovation, and influencing many aspects of our daily lives. From virtual assistants and systems to data analysis, artificial intelligence has become a major part of our modern world. Today, we have two subject matter experts here to talk about AI. First, I'll introduce Mr. Matthew Adams, branch head at the Naval Enterprise Research Data Science Branch, or NERDS for short. Mr. Adams is a seasoned software developer with a Bachelor of Science degree from the University of Central Florida and over 15 years of experience. Mr. Adams, the podium's yours.
Welcome back from lunch. Hopefully, I'll keep you awake through this little presentation, but I'll get started off by just kind of introducing myself and the team a little bit. So we named ourselves the Nerds, right? And it's a fun little name. It's easy to remember, but it does make for some interesting conversations, particularly when you're on a call and somebody's unaware and they're like, oh, we'll just have the Nerds do that. And they get kind of like, is that, okay to say? But we did choose that name. So we got started back in 2017, and we were stood up to respond to kind of bringing this AI data science technology into condition-based maintenance for NavAir. And we are located in Orlando, Florida at the Naval Air Warfare Center Training Systems Division. And you might ask, why is the Training Systems Division Warfare Center trying to tackle AI and data science for condition-based maintenance and the operational? And that's kind of a long story, but really it boils down to two things, which I'll talk about. But so we're a government team, and over this time, we have built out a high-performance compute capability locally at TSD, and that's where we do all of our work. We process something in the order of 10,000 flights per month, billions to trillions of data points, and we're constantly analyzing those to enable predictions of premature part failures that are outside standard, scheduled-based failures. And so we look at that in order to kind of enable better maintenance schedules. So one of the reasons that it is down in Orlando is our talent pipeline, right? So we are situated right next to the University of Central Florida, which is the second largest university in North America. And we have, in fact, I sit in a UCF building. And we have found that talent in this area, and I'm sure all of you are aware, is incredibly difficult to find, right? It's difficult to find, and when you can find it, we can't afford it. And even like the primes are having a hard time affording it, right? Because you got OpenAI offering them $1 million a year, and that's just difficult to compete with. So what we found is we'll just get them while they're still in college, right? We hire them while they're juniors, seniors, take them part-time, and then we train them. And then we get them hooked on the mission, we get them plugged in, we get them, in the data, and then they stay on. And then we'll pay for higher education, we're continuing service out of them for a few years. And then honestly, at about that 5-year mark, they're worth so much in industry, we lose them. But that's okay, because in that time now, they were feeding into the next set of interns that we've brought in and training that next pipeline. And so with that, we've managed to grow to 27, but we've actually just hired another guy, so 28. And we got 4 more interns. We started hiring the interns in batches of 4. It makes it a little easier to train them all at once. So we're constantly keeping that pipeline full, because it is a leaky pipeline. But as far as I'm concerned, as long as they stay in the defense industry and they go to industry, I'm happy, because we're all on the same team. So that's one of the reasons it's there. We got the talent pool. So I do want to take a moment, just lay some so we're talking about the same thing about where academia, industry, and government are kind of all fitting in when it comes to AI, right, and standards. And so on the academia side of the house, right, our expectation is that they are pushing the state of the art. They are taking those risks. They are experimenting, exploring the trade spaces, trying to figure out what works, what doesn't work, doing some of the things that are a little riskier and harder for us as the government to necessarily explore, and then also training those experts that we're able to consult with or hire, maybe if we're lucky, right? Industry now should be taking what the government thinks they need, says they need, and trying to figure out what we actually need, right? And then matching that to the technology that is being developed in either academia or in internal R&D, right? And then mature that to a state where it can be delivered and maintained. And then, and this is why we're here, right? The government should be defining requirements and which standards that they want those requirements to match. And then they should be verifying and validating that the solutions match those requirements and those standards. And for the AI specifically, and we'll talk a little, they should also be standing up and maintaining some infrastructure to support that capability. and then taking care of the data kind of management and curation and that sort of stuff. And of course, right, we're going to try to ensure best value for the taxpayer. And part of that is not trying to solve the same problem over and over and over and over again. And as the panel was talking about earlier, one way we do that is with standards, right? Standards help us reduce the need to reinvent the wheel over and over again. So, couple challenges. So, over in our group, we sit in a weird kind of two sides. We kind of straddle the line. In the Warfare Center, our job is to kind of take these emerging technologies and help the programs understand how to define the requirements for those and to kind of help them understand what technology is the right fit for their problems. So typically the world that we're working in, there are no well-defined or well-accepted standards, right? And by the time there are standards, we're moving out, right? That's industry's job now, and we're off to go to the next problem. And I've been there 15 years, and we've probably done this 4 or 5 times now, where we've grabbed onto an emerging technology, helped explore the trade space, help the programs understand, help them write their requirements and standards, and then move on to the next emerging technology. So AI is the same but different in that regard, and so that's where we're at now. But so we get to kind of sit on both sides. We're active practitioners in AI. We're working it every day. I mean, we're applying it to real world problems, but we're also trying to help the programs understand requirements and standards. So AI in particular has an extra level of complexity and from some of the other technologies that we've worked with. And here's just some numbers from the Stanford AI report. It's outdated. They have a new one out now, I think. But this is an absolutely wild field. I feel like every time I blink, there's just a new groundbreaking research or a new technology, and so first off, it's really hard to standardize on something that tomorrow could completely change, right? And so that's one challenge. And the other issue is looking at the costs there, right? It's expensive. It's really, really expensive to do this stuff, and so it's very difficult. The concept of kind of throwing spaghetti on the wall and seeing what sticks is kind of hard to do when that's each strand of spaghetti costs hundreds of millions of dollars. So that's also a challenge here. Security, and so this is something that was kind of hit on earlier, is standards tend to reveal capabilities, and when we're talking from a government perspective, we don't want to reveal our capabilities to potential adversaries, and when we're talking from an industry perspective, we don't necessarily want to reveal those proprietary things that make that vendor special, right? And just give it away. And so how do we balance that with still making it interoperable, but not giving away the secret sauce, if you will? And the other issue is within the DoD, a lot of the programs that we want to apply AI to are some of our most sensitive projects. And so they're basically information black holes. We throw data in, but we never get anything back out. And so it's very hard to take those lessons learned out of those programs without super high clearance levels, which again limits the amount of standardization we can apply. Data rights, right? And we talked about this earlier, but data rights is a huge issue. And again, I think that's going to be part of trying to figure out which bits of data we need as the government in order to standardize, and which bits industry needs to keep in order to hold the proprietary edge. And then the last bit, which we'll kind of spend the rest of the time sort of talking about, is the requirements. And I come from NavAir, right? If NavAir has a requirement to build a weapon system or an aircraft, they're really good at breaking that down to all the way down to the bolt and fastener level, and they know what standards apply to that, and they can decompose those requirements down to the tiniest level, and we've got decades of experience doing that. Less so on the software side. And then when it comes to AI, most of the time when it comes to me, they just go, I want AI. Okay, but there's a lot more to AI than just AI. So in talking about that, this is what I use to kind of walk the programs through it. And you'll find a dozen iterations or variations of this on the internet. But it starts with a requirement, right? I need to do X. And a lot of times we skip that right now in the government. We don't go, I need to do X. We say, I want ChatGPT. Well, okay, but why do you want ChatGPT? What do you need it to do, right? First, let's start with the requirement. Then once we've decided that AI is the solution to that requirement, which it probably isn't, but let's say it is, right? Now, okay, we decide what it needs to do. Now we need to start decomposing that, right? And so below that, we got the data science work that has to be done. And that's people, right? That's people and tools. And they've got to be able to understand the data, explore it, and more importantly, validate the results of the AI out of the system to ensure that it is matching what we want. Beneath that, we got data engineering, right? This is a section, a slice that often gets ignored, but it is a huge level of effort. This requires a ton of work to collect, move, aggregate, store, process, clean, deliver the data to the data scientists in order to do it. And to be honest, in our work, the data engineering is one of our biggest friction points. And it is a huge amount of work that often gets ignored. And if done right, nobody ever sees it, right? And so it's one of those tough ones. But when it goes wrong, it goes very wrong. Tools and software, right? And so this is an area where if you just you go look at the chart, the ecosystem of AI, and they keep shoving more and more and more apps in there, and it's like, which one is the right one? And if you ask them, all of them will tell you they're the right one, right? And they can do everything from this whole pyramid. They'll take care of it all. And so how do you know what's the right one, and how does that fit into my ecosystem? And then this one's a big one, right? Cyber and IT is basically it's got to go hand in hand with AI, because there's a natural kind of conflict here. As a data scientist, I want all my data aggregated, right? I want it all in one place, and I want it all tied together and easy to use. But I just created kind of the greatest cyber target on the planet if I do that. And so from a cyber perspective, I want to keep my data isolated and separated and secure. And so the only way we're going to solve that is if we come together as the AI team and the cyber team, and we are basically one team. We can't be two separate teams. We have to be one team. It has to be included from the start. And then the big one, right, again, is infrastructure. And you've heard it hit on a lot, is infrastructure, where we've got to provide. AI in particular requires enormous amounts of infrastructure, more so than all of our previous software that we have done, right? It has a special blend of infrastructure requirements, and DoD HPC is working to move towards that requirement, but it is just a massive requirement. I did a tour out with DIU out at the Silicon Valley, and talking with some of them where they're saturating entire AWS regions when they're validating their AI, right? That is mind-boggling for the DoD, right? And the solution it can't just be we're going to use AWS, because what happens when we're in an IMCOM condition, deployed out at sea, and we don't have access to the cloud? That's just not going to work. So we have to come up with different solutions. So, and I think it was mentioned, right, when in the panel where we talk about how those things may be changing in each one of these little slices, but if we can standardize on the seams here, right, then it doesn't matter. So what we need to do is actually work on trying to standardize as much as possible the interaction between these systems, so that I don't care what goes into it, it all just works. So to lay this out slightly in a different kind of layout here, I've kind of put this is kind of like the where AI will be used, and I kind of put it in two categories, where you got web tools on one side and edge deployment. And why I separated that is the edge deployment has special requirements, right? That's out in the field, on the ship, on the plane, and those have really special requirements. Again, like if the internet goes down, it still has to work, because it's going to go down. If there's attempts to degrade it, it still has to work. So much higher rigor. The web tool side of the house, right? That's more like stateside leadership. We're working over here, or even the AI developers themselves. If we go down for an hour or so, it's probably not the end of the world. We can probably be a little more reliant on commercial services, that sort of stuff. So kind of two categories, but in the middle is still infrastructure, right? And this is the kind of the tie-in here, where you've got, and I kind of split this up, right? Storage is a form of infrastructure, right? But when I built our first HPC back when I was a young, naive engineer, right? I severely underestimated the difficulty in storage. I now firmly believe storage is the hardest part of infrastructure. It is staggeringly difficult to do right. And so I kind of separated them. But on the infrastructure side, we've got cloud, GovCloud, right? We've got DoD HPC, on-prem, edge devices. How do we distribute our compute and put the AI where we need it to be? And storage, how do I get that stores from a disconnected system in the field to data centers stateside for processing or retraining, et cetera? right? And then in the middle is, again, cyber, right? Cyber has to tie all of this together. Everything has to be looked at through a lens of security. And the idea is we should be kind of centralized, and the Navy is allergic to the word centralization. So I have to be careful when I say that, but we have to centralize some of this because this is going to require an investment on a scale for infrastructure that we just don't that isn't normal. And I think we're underestimating the complexity that we're going to have to solve here. And I can only really speak for the Navy way because that's where I've spent my career. But the Navy way is we're just going to let all the programs figure it out, and they'll eat each other, and the winner will come up with the best solution, right? And it's worked. It's worked really well. It's maybe not the most cost-effective solution, but we've gotten really good technical solutions out because we go out and each PMA, each program goes and finds a vendor and they say they can do it, and we invest and we get this broad base of expertise, and then eventually standards form and it bubbles up and we get the good solution. But AI, again, same but different. And different is just the scale of cost and the complexity that I think we're dealing with. And so I think we're going to have to take a slightly different approach. But to look at it from where these standards should live, right? The problem that we have now as AI practitioners in the DoD is if I build a really cool AI tool that serves a requirement, I have to, before I can use it, I have to become an expert in how to deploy that on infrastructure. I have to become an expert in cyber. I have to become an expert in whatever the edge deployed solution is for that particular, program. I have to become an expert in how to host that within DoD. I have to become an expert in how to manage the storage. As a team, we have to become experts in this entire landscape, and that severely limits who can participate. And we have a lot of really great small vendors out there that have really awesome tools, and they're calling us up saying, how do we get this to the people who need it? And they just can't because they are required. They'll say, yeah, great. I need you to go get that hosted and deployed, and then we'll use it. And it's a team of 10 or whatever, and they have a really great product. So if we can kind of basically abstract out those seams to where vendor has a tool that does, let's just say, image recognition, right? I can just plug it in on either the edge side or the web tool side, and it hits a particular API, and that's it. They don't have to worry about which, whether it's running on the cloud or DoD HPC, right? The program can decide that based on their budget and, requirements and things like that. So that's kind of the gist. And I put a couple examples there on two of them where we are working on this, right? And DIU, I think 2 years ago now announced a project, and I think they're getting ready to kind of roll it out with Rescale and Parallel Works, where they are blending the cloud and DoD HPC, so you can send jobs out, and then it'll work on either based on availability and demand. So we're getting there. And then CDAO recently announced the Open DAG standard, which we have not a lot about yet because I think they're having kind of like a Q&A session coming up. So, but the idea being is, again, that concept of not having to necessarily worry about the storage side. They have a defined layer for access. So hopefully that takes off and it is well received. So kind of to wrap it up here, and I kind of did a bait and switch on you guys, right? AI standards, and I kind of switched out for infrastructure standards. And I'm excited to see on the schedule that later this afternoon, there's going to be some conversations about infrastructure standards, because without infrastructure, AI is useless. And our infrastructure is inadequate right now. It is either unavailable, unaffordable, or just not there, right? It just doesn't exist. And unfortunately, when the gentleman here was talking about how we have needs that industry doesn't, industry is not going to solve our problems of being able to run this stuff on a ship in the ocean disconnected without us asking for it or driving or kind of pushing for it, right? Because Amazon doesn't need that. And I get calls all the time where they'll go and tour FedEx, and FedEx has a really amazing, condition-based maintenance program that they use for their fleet. And Naviair comes to us and says, why can't we do that? And I'm like, well, FedEx doesn't have to work when bombs start dropping, right? There's a very different set of requirements for our systems. And so we have to work on the infrastructure. And unfortunately, given the cost, it is going to have to be somewhat of a centralized investment in standards wrapped around it so that everyone can use it. And then on top of that is people, right? And this is that challenging part of where we have to have a trained workforce because, again, going to being how do we decompose these requirements from the government side, and then from industry side, we got to have the people who can actually take this technology and apply it appropriately to the systems, and then develop the standards that I'm talking about so that we can move faster. And I did appreciate where they're talking about standards let you move faster, right? Because again, if we develop these standards, that's a bunch of standards, but man, now we can really start going. And then cyber alignment. So if I can kind of sandwich between those, infrastructure and cyber, we gotta tie those two together, and we have got to start focusing like initially on cyber. And I'm not saying we're not, because there's tons of focus on cyber. I think for the most part, we've been hammered how important cyber is, and it really is. And then once you got all that together, now the standards can really shine, right? Because if we define a standard for AI about how to implement, image recognition algorithm, it's kind of useless to me right now, because I implemented it, but what good does it do me if I don't have the actual system with which to receive that standard implemented system? So that's kind of all I got there, short and sweet, but I included some links to those projects I was talking about, and I guess questions.
You talked about the need for standards. So are you currently working with any standards development organizations on any committees to push some of these? Or do you need references? I'll give you SAE committees you can get involved with.
Yeah, so that's one of the challenges that I kind of alluded to in the security side is, unfortunately, a lot of the DoD is working on AI standards, but they are not publicly releasable, right? And in some cases, they aren't even unclassified standards. And so how do we collaborate outside of that bubble, right? And there are efforts going on with our allied partners as well, developing standards and interoperability. But again, nothing that can be discussed at this forum, right? And we are involved in that, but I think, and this is kind of almost maybe even like a plea for help, right? Because we get stuck in this security bubble, and we have a hard time kind of going outside that when, again, some of these standards, so like, let's use Docker as an example, right? That's the Docker image standard is really great and useful. And that's very similar, like that fits one of the billets here, right? Where I can deploy a system and we're using that. So unfortunately, like I said, some of those things just aren't quite, what we have is not quite the same need. We have those little extra requirements, and we've got to get better at figuring out how to detail those and share those with you guys so that we can work together to come to a solution.
Yeah, I think there's definitely things we can do to help you out and get you some contacts. Even working, it sounds like a lot of the work that you're doing is even almost pre-standards, which we could bring in something like SAE ITC with Pete sitting over there, or a similar organization that would give you the forum to start discussing these and start determining what should be in standards that can be declassified to a certain extent.
Oh, there we go. I was wondering how you're leveraging commercial standards efforts and industry standards efforts, particularly for office and business applications within the standard, within a typical DoD organization, particularly for business applications apart from operational applications.
Yeah, so not really my area. I'm more on the operational side, but what I can say is our CAO office is actually doing a really good job of adopting those standards and pushing those tools out via Advana and Jupyter and making those things available. And we've got, for kind of that business side of the house, right, that seems to be where everybody's moving. And CDAO has done a great job there of kind of growing that ecosystem, adopting standards so that we're able to bring in more commercial tools and make those available. We as NavAir love Click and Tableau and Power BI, right? And so now that ecosystem has really started to grow, as well as now we're in GovCloud with Advana, and we can do all kinds of kind of distributed processing. And so, yes, absolutely for the business side of the house, and again, that goes kind of more like the web app side, but that's a little easier to use those commercial standards because we have less of those kind of extreme requirements. And so absolutely, that's certainly where we try to maximize our utilization of those types of technologies.
Do you find like the concept of elasticity when it comes to using the cloud to be something that at least the Navy is willing to tackle, not just from the cloud, but from the mix of cloud and on-prem? Because I feel like that has to be elastic as well to meet the need, but that's not necessarily something that we in government seem to be very good at, being dynamic like that. How do you tackle that sort of thing?
Yeah, I mean, even just like the mundane billing and payment aspect of Elastic on the cloud is problematic within the DoD, right? But we are working on it, and I think really our Elastic, the best we're going to get. Like I said, we maintain like an on-prem HPC, but nothing would please me more to like sunset that and get on DoD HPC. But we use DoD HPC as well, but I think DoD HPC is going to be the answer for our kind of cloud, unclouded kind of elastic growth. And just because, again, HPC is one of those things where huge investment is required to stand it up. And so it doesn't make a lot of sense to have every program go do it on their own. And so I think kind of DoD HPC is the answer for how we're going to handle that on both the cloud and kind of on-prem. The missing link we have, and the Navy has some solutions, but for the deployed side of the house, right? Now we got to close that bridge, that last over here. Now, how do we have cloud on the edge? Anything else?
I have a question over here.
Yes.
So, you talked about the edge, being able to use this on the edge. Can you talk, and it might not be so much standards, but you have to know what the standards are for the edge. And if your infrastructure isn't there yet, I'm not sure how you're going to do that.
Yep.
But then how do you develop your applications that you're going to use on the edge without having the edge there? Over.
Yeah. No. So from experience, what we have done is we have leaned on existing systems, right? And we've kind of just shoehorned them in order to, because that's the fastest route for us. But yes, what we are working with some other groups to say like, hey, well, we don't do the physical hardware development or anything like that. So I can't really speak to that, but they have requirements like, hey, it's got to be able to survive, this type of shock, all those standards that have been developed over time. And what we're just adding in is hey, how much compute do I need? Right. And so that's what really the bit that we're adding in is all the same like physical survivability and redundancy requirements. But what I'm adding in is basically like, I need a GPU on there, or I need some sort of inference engine on there, or et cetera, right? And so that's really, they're not there in fielded practice, but we have prototypes out there, and we have certain stopgap measures that we're able to at least test and utilize.
Sure. Maybe to follow up on that, are you addressing any AI networking standards? Like we've seen proposals by NVIDIA for 5G. Networking things, would you consider that as part of your purview?
I have no idea. I imagine we are, but not that I'm involved with. We're barely connected on these AI systems as it is. So kind of like networking is kind of like step 2 or 3 for us. But as far like from our perspective, but I'm sure there are people working on it, but I am not unaware.
Yeah, I've had the pleasure, and I say that a bit sarcastically, of having to get unique programs approved on Navy systems
Mhm.
and Navy computers.
Yep.
I can't imagine how hard it is to have an AI type program approved, but I was wondering if you could talk a little bit about if you've been successful doing that and how you were able to accomplish it if you were.
Yeah, so the short answer is it's not difficult, it's impossible. And as far as I know, every AI system that's running in the Navy is operating on an interim ATO, right? Like there is no fully approved end-to-end ATO'd system yet. And part of that, and that's part of the process, right? And that's part of what our job is to start doing these things, do these interim ATOs, work with our cyber team so that they can understand what the threat profile is of these things. How do we understand? How do we use them in limited cases so that we can help inform those risk decisions and say what is a good risk and what isn't a good risk? Because to be honest, we don't like, as a, we'll say, organization, understand AI, right? And it is very complex. And so to be able to make these risk-based decisions, you got to have the data. And the only way we can get it is by doing these kind of, prototypes and fieldings. But unfortunately, it's kind of a chicken and egg thing. It's hard to do a fielding without an ATO or cyber approval, but you can't really get that cyber approval without proof that you're not. And so, and we're having the same thing with airworthiness, right? And they mentioned like the FAA work and stuff like that, which we're leaning on. That is something we're leaning on. But the same problem, though, like they've never done it before, so they don't understand the risk. So how do you, it's kind of chicken and egg. But yes, it is basically impossible right now, but we're working through that.
All right, thank you. And thank you for making the trip despite the hurricane, right? Our next guest is joining us virtually because of the hurricane and all the rain down south. So it's Mr. Robert Keisler. Did I get your name correct?
You did. Keisler.
All right. He's a senior science and technology manager and director of the data science and AI for the Naval Information Warfare Center. Mr. Keisler serves as the NIWC Atlantic's managing executive and senior technical expert for data analytics and artificial intelligence. Over to you.
Thank you. Good afternoon, everyone. Tropical Storm Debbie kind of threw a wrench in my travel plans to be there in person with all of you today. But I'm honored to be able to talk to you virtually about standards in the age of AI and share a little bit about how our organization has begun to rally around some of these standards and emerging best practices. Next slide, please. AI is integral to future competition, and not just within the defense space, but the nation as a whole. In October of last year, President Biden signed the executive order on the safe, secure, and trustworthy development and use of artificial intelligence, which over the past few months is changing the landscape of AI standards in the federal government, and something we really need to pay attention to as things are developed. Next slide. AI is defined in many ways, but for our general purposes of this forum, AI is the theory and development of machines able to perform tasks that normally require human intelligence, such as visual perception, understanding, and generating language, and automating aspects of decision-making. Now, I always want to start with that because definitions change all the time, and everyone will give you a different definition for AI. But AI is often misunderstood as this monolithic entity, but it's really a diverse field and range of technologies. And its essence lies not in the singularity of what AI is defined or perceived as, but in its vast multifaceted capabilities. In fields adjacent to AI, such as process automation, robotics, data science, are revolutionizing the way we work, operate, and make decisions from the battle space to the boardroom. And this transformation isn't just about new technology. It's really about reimagining how we solve problems and create value. Next slide, please. AI is powered by this flywheel. We have mission problems that could be, and in some cases already are, enriched by AI solutions. By understanding these problems better, we create better algorithms. Better algorithms lead to enhanced mission outcomes, which then opens up new avenues for use and deployment, and which then finally further enriches our missions. Standards around this flywheel are crucial for several reasons, ranging from ensuring safety and reliability to fostering innovation and trust. Standards for AI facilitate interoperability, allowing different systems and AI components to work together seamlessly. They help us address ethical concerns by setting policies for responsible use. And standards provide clear guidelines for how AI systems should be developed, tested, and deployed, providing benchmarks for compliance. Standards in AI could even help us ensure that the development is sustainable. This is a huge concern that's only just now really starting to show up. This includes in addressing environmental impacts, promoting energy efficient technologies, and considering the long-term societal implications of these technologies. Next slide. Now, when implementing AI, organizations typically invest their efforts in two scenarios. In the first, less common scenario, AI is developed for relatively benign tasks that don't pose a significant risk to mission. While this isn't always an effective use of resources, everyday AI's potential to enhance a human's abilities without significant operational risks and the growth of generative AI technologies is increasing the usefulness of this approach. Furthermore, what we're seeing is much of the AI deployed in the future enterprise will be embedded in everyday off-the-shelf products we already use and may already be today. Now, the second, more common investment scenario involves developing AI in critical areas where the benefits substantially outweigh the risks and costs. This approach focuses on strategic applications where AI's efficiency and capability justify the investment, despite the potential for errors in the cost of developing safety nets. These AI systems must be integral to achieving significant competitive advantages and operational improvements. Now, our organization talks about this through the lens of a use case process. We have learned to start with a mission engineering lens, focusing on if AI is the right fit. And if it is the right fit, does it deliver measurable value through measures of effectiveness, measures of performance, by maximizing the probability of success and/or reducing uncertainty in the way that we make decisions? Does it actually cause us to fundamentally rethink how we operate? AI can do that. But we also need to standardize how we document and review our use cases by utilizing AI inventories and catalogs and through governance structures, things which don't exist today. Next slide. The concept of an AI factory is essential for better algorithms. It ensures that AI engineering and development processes are standardized and repeatable. This ensures that AI products are produced with quality and maintain compliance with regulatory requirements and other industry standards. This standardization also helps us with the scalability and efficiency of the infrastructure itself. Now, Matthew, the previous speaker, talked a lot about this, about the infrastructure and our need there and issues there. So he covered this in depth. So I'm glad he spoke before me. Locally, we have taken an approach of defining a generalized reference architecture for groups to align around as we work through the programmatics on how to centralize major AI factory deployments. And again, as Matthew stated, centralization can be a bad term to some folks. Now, data standards is another area, and I don't really want to go in depth on this as they have been around forever. But AI is fueled by data, of course. 80 to 90% of the work is just getting the data in a state to use and learn from. What we've seen, though, is that the standards exist, but they were developed a long time ago. And to meet modern demands of new IT systems, we've overloaded them in ways that were never intended. This creates issues getting the data right for our data teams. Furthermore, in my personal opinion, integrating AI into systems affects and highlights the need for more specific data-related key performance parameters in the ways that we assess and develop our programs. Next slide. For enhanced mission outcomes, the unique characteristics of AI, such as its non-deterministic nature and socio-technical impact, require an evolution in our standards for testing, evaluation, and monitoring. Unlike software that is deterministic and produces consistent outputs for given inputs, AI systems generate probabilistic outputs, making it essential to account for this uncertainty in their evaluation. Implementing mechanisms to detect data and concept drift is crucial to identify when the system's performance degrades. This continuous monitoring aspect cannot be overlooked as testing and risk management standards evolve. Traditional software-like testing methods are insufficient for AI. We need multifaceted approaches that include stress testing, scenario analysis, and adversarial methods to uncover future potential failure modes. And we must also understand how humans interact with these systems. This is a different way of thinking about things. We don't generally think very heavily about the human aspect when we develop standards for what might be under the IT umbrella. And this includes studying user behavior, expectations, and the impact of AI on decisions. Now, NIST, DoD CDAO, with their responsible AI initiatives, and other government agencies are working to update standards around these needs. A lot of this work is derived from the executive order I talked about earlier, but they are new and emerging, and adoption and enforcement isn't quite there yet. There was a question a minute ago about how do you get these things approved? And it's almost impossible because there are so many things that are changing as you develop these systems. And this current guidance is also very broad and general, and sometimes very difficult to translate into executable tasks for how my teams assess and assure that AI systems are safe, secure, ethical, and effective. Now I'm working to try to keep our teams in the loop with these standards, and we're using our own internal R&D investments to build out an AI test and evaluation workforce, much like we had to do for cybersecurity. Next slide. Building appropriate teams, ensuring AI literacy, and developing standards for human-machine collaboration are critical steps in using AI well. These areas allow us to harness AI's full potential while mitigating its risks. AI is a team sport, and not just the technical teams that develop these solutions, but human-machine teams as well. On the technical side, we have established role standards, working with OPM, DoD CDAO, our own Department of the Navy CDAO, and using our own knowledge developed over the past 12 years as we've built out our own workforce. Data scientists, AI engineers, data engineers, and others must have well-defined responsibilities, skill criteria, and certifications to ensure alignment and accountability to the tasks they perform. Now, we have two easy avenues for this today through the OPM 1560 Data Science Series and the new DoD Cyber Workforce Framework, DCWF, Data and AI roles. Now, at my command, we've also centralized our data science and AI people organization. We're a matrixed organization, so I'm the people leader over that group. We did that stand up in 2017 after building out that cadre since 2012 in smaller management structures. And now we have over 100 engineers, scientists, and IT specialists in data and AI roles. Now, as we grew, we found building teams, technical teams, was crucial. And we started aligning around this concept that we borrowed from others called strike teams. And the strike teams consist of a mixed group of data scientists, data engineers, AI engineers, paired with other roles depending on the problem being solved. Usually we try to pair with someone from the problem itself, whether that's a warfighter or a business user or someone from human resources, someone from finance. We bring them into the team itself. This construct of strike teams has also allowed us to grow our mid-career team leadership significantly without needing to rely on new managers and new management structures. And those team leaders are crucial to getting to scale. Now, on the human machine side, developing standards for how AI presents itself to users is also vital. This includes user interface design, transparency of AI decision-making processes, and clear communication of AI in use, its capabilities, and limitations. Now, these standards are nascent and they're being developed by industry primarily, and we're trying to incorporate some of them. But to get ahead of this, we tried to build some of this practice by training our workforce in concepts of human-centered design and really focusing our engineers and scientists on understanding the human part first, centering there, and then going backwards. So it's a way for us to bring these standards in while they're being developed. Also at this point, AI literacy is essential for everyone. I just want to bring this up. This isn't really a standards thing. You could say that we need AI literacy standards, but I have to hammer this every time I talk. In my opinion, AI literacy is no different from cybersecurity literacy we all have to go through every year. This includes understanding basic AI concepts, its potential risks, and the ethical implications of AI. This is because AI is around us everywhere today. You used it multiple times today already, even if it wasn't obvious to you. And that's almost a little scary, even for someone like me, who this is my job, my career, and I understand it very well from a technical perspective. The way these algorithms control parts of what we see, how we act, and how it will affect us in the future is very concerning without a basis of literacy. Now, we've done some efforts to teach this literacy through online and in-person classes, but we really need to get at a larger reach. Next slide. Now, for AI, standards are nascent but critical. There's a lot of churn and development going on at all levels. Half of the problem I see with these standards is just keeping up. The new executive order put a lot of pressure to develop these things quickly, and they've been popping up left and right. I think about every couple of weeks, a new one or a revised version of one has shown up. And the other half is figuring out a way to put them into practice. And this is very hard. Really putting them into practice in the way that our teams execute, the way that our tools work, working with industry to make sure that what they're developing is fitting the right standards and the way that we need to operate. This is a very hard problem, and we're building this ship as we sail it around. And it's going to take time, focus, and leadership to do all of this, but we must press forward. And with that, I think next slide, I will take any questions you might have. I wanted to leave a little bit more room for questions because I'd rather talk to you all than speak and just ramble on for a while. No questions?
No questions? Is there one in the back?
I'm trying to form it. Maybe if I had Chat GPT, I might do better. But I have, I mean, you're talking about being able to, it's probabilistic. Is there a way, if you're, and you're trying to look at the human decision maker? You're not? Okay, sorry. So for the decision maker, is there a way to get not the most likely, you're going to get, it's going to tell you, here's what the most probable answer is. Is there a way to look at those answers that the AI rejected?
It depends on how on the type of algorithm you're using, but yes, for many applications, there are ways for us to display the other options that the AI thought about when it made its decision. And you'll see a lot of that. There's a lot of initiatives going on with explainable AI, trying to have the AI explain itself and its reasoning and the decision, why it made the decisions it did.
Oh, that's good. I think that will do a lot to help with the trust and confidence.
In the back, and then
Hey, can you hear me? Okay. So I have a question. I hear you talking about, we need to train people, but I think the DoD, we don't have enough GPUs. Our infrastructure is really not set up necessarily to handle the machine learning and whatnot that needs to go in to create the AI. Is that a concern as well for you?
Infrastructure, I think the previous speaker also covered this a little bit. Infrastructure is a huge concern. It's something that I think senior leaders, I know in the Navy, because we've advised them, are aware of and trying to tackle. I know that DoD CDAO has a similar approach. What I would say is that understanding of what we need, it is more important than just saying that we need it. We have to understand what use cases we're going to solve and then going from there. There's plenty of avenues to get at that infrastructure, at least from a cloud perspective. Now, as Matthew covered, cloud doesn't solve all our problems, especially with the Navy when we have ships at sea. But understanding what use cases we are onboarding onto our platforms and what kind of performance capabilities they need, we can solve those infrastructure problems pretty easily by understanding what kind of hardware they need from a technical perspective. Now, you're talking programmatics and other things, that takes years. So as far as training people, what we found is that's not a big deal because we can, again, get them the resources they need as far as GPUs, whether it's we've got our own machines in-house. We have access to DoD HPC, as was mentioned. We can get access to cloud resources. We can get access to tools. The DoD has the Advana platform. The Advana platform, for those who don't know, is kind of the DoD's standard data repository. The Navy has a enclave of that called Jupyter. So a lot of my folks are working in there, and it has its own hardware aspects where they can do some of the work that they need to do. But yeah, I mean, the biggest issue I see on the infrastructure side is I don't think people really understand the cost models and aren't prepared for the funding. What we found is that money gets burned up very quickly on compute, and it's concerning a lot of leaders today.
all right. Leslie?
That was an extremely interesting presentation. Thank you very much. It was very rich in information. I had a question about the training component as well, but I think you've answered it. I was wondering if you could speak a little bit to your strong statement regarding start with the human component and work from there. Could you give any kind of like a case or example of real world of that scenario?
Sure.
Help me understand exactly what you meant there.
Yeah. So the first step in really any AI process should start with the decision maker. So AI is really the algorithms, what we're solving, all the technical aspects. It's really about helping a decision maker maximize their probability of success in the way that they make their decision. And so the best way to start is with that decision maker, understanding what decisions they're trying to make, understand what data they use to make those decisions, what data may be available that they don't have to make those decisions that we can help them make a better decision. but really understanding the foundation of what AI is trying to solve. So if you're thinking about a simple, I'm trying to think of like an unclass version of this. Let's say image recognition, and you want to identify ships in pictures of the ocean. Well, we can do that. We can tag all the ships we see, but is that really helpful to the user? Or are they really wanting to know, are these ships of this type in this area doing these things with this, parameter, et cetera, et cetera, et cetera? And get those specifics out of the user. And that's really where starting with that user, that human first, and really understanding what their decision-making process is and how AI will enhance that and enrich that is critical. I hope that answered the question.
It did. I've got one more minor follow-up, unrelated. You and the other presenter both spoke to AI. We're sort of tripping over ourselves about saying GAI, AI, always trying to explain the difference. We write AI/GAI. Are you at this point just kind of abandoning and just calling everything AI, or do you think it's important to differentiate between AI and Gen AI, the predecessor to current Gen AI?
And this is my
Structure and we'll follow it.
yeah. This is my opinion. Everything AI is the largest umbrella. Gen AI is a subset of that. Generative technologies are actually multiple different things. You tell someone Gen AI, they think ChatGPT or Claude or whatever tool that's out there today. But it's more than that. There's actually a lot of different algorithms that make up that generative umbrella. But at the end of the day, it's all AI. That's my opinion. So if you're talking about, I wouldn't personally, I'm also a purist. I also don't write AI/ML, which you'll see a lot too, AI and machine learning, because machine learning to me is a subset of AI itself.
This is Chris Catati from PEO Stry in Orlando. Are you or anybody in the participating audience here participating in the AI Standards Coordination Working Group that got stood up amongst U.S. government starting about 3 years ago? Over.
I personally am not. I have heard of a number of standards groups that got stood up. I believe DoD, CDAO also stood up their own standards group. I was involved in some other groups for them, not the standards one. I do believe we had some Navy POCs that were on that standards group. I'd have to go back and figure out who they were and if it's still ongoing and if it's connected to that other forum.
Just wondering, I had signed up and I'm on email distribution, but didn't have time to participate and not really the knowledge. It's not up my interest alley, but not my technical knowledge area. Over.
I have an online question that I'll read to you. It seems that bad actors are accessing AI faster than us. For example, deep fakes, China, etc. Please comment.
So I would say to that, I don't know that they're accessing it faster than us. They don't necessarily have the constraints we do in some cases, but in my personal opinion, I'm of the group that believes we should do things the right way. We should lead the world in the way that we develop AI. AI being a critical human technology, we should develop it in the way that we build our own society, respecting human rights, all of those types of things in a responsible way. And that's also how the DoD has defined how we're going to develop AI. And so I'm on board with that. And I believe that going fast doesn't necessarily mean doing it well or right or in the best way and making the right investments. And the attacker is always going to be faster than the defender. We see that on the cyber side as well.
All right. Thank you, Robert.
Thank you all.